Welcome to qnawire.
We'll answer a couple of questions about the continuous uniform distribution function. So the probability density function of this distribution is shown in the slide. And first we have to calculate this probability density function when a equals to 0 and b equals to 1. So for this interval, the probability density function will look like the following. So it will be 1 when u belongs to the interval from 0 to 1, and it will be 0 otherwise. So it will be 0 for all the other values of u. So now we have to prove that if two equal intervals are chosen, the probability is the same. So let's choose first the interval from 0.5 or from 0.25 to 0.5. So in this case, the probability will be equal to the integral from 0.25 to 0.5 of probability by du. So this guy equals to 1. Therefore, we can simplify this integral. And it equals to 0.5 minus 0.25, which is 0.25. Now let's choose a second interval, which is, for example, from 0.5 to 0.75. So the probability equals to the integral of the probability density function. So again, this function is 1 for this interval. Therefore, it equals to the integral of du from 0.5 to 0.75, which is exactly 0.5 minus 0. Sorry, which is exactly 0.75 minus 0.5, which equals to 0.25. So those probabilities are the same. Now we've answered the first question, the question A. Now we have to answer question B. In question B, we have to calculate the cumulative distribution function for this continuous uniform distribution. So as we know, cumulative distribution function for a continuous distribution is calculated as integral from minus infinity to u of a probability density function. So now let's split all the numbers from, like, all possible values of u from 2, 3 intervals. So the first interval will be for u below 0. So in this case, this integral equals to the integral of u from minus infinity to u, probability density function. So this function is 0, as we know from the task. So therefore, this cumulative distribution function equals to 0. So in the second interval, u belongs from 0 to 1, including these numbers. So here, the cumulative distribution function will be calculated as following. So again, the first part doesn't change. And now we can substitute this integral with the sum of two integrals. So the first integral is the integral from 0 to u of the probability, of the probability density function. So this guy plus integral from minus infinity to 0 of the same function. So the second term equals to 0. And again, this guy equals to 1. Therefore, the first term equals to u. And when u is above 0, again, we can calculate the cumulative distribution function same way. So now we have to we have to reduce it to the sum of three integrals. So the first integral from minus infinity to 0, which is obviously 0, then plus integral from 0 to 1, plus integral from 1 to u. So these two guys equal to 0, and the same as, these two components equal to 0 because the probability density function is 0 at those intervals, and it equals, so the overall cumulative distribution function equals to the integral from 0 to 1 of the probability density function, which equals to 1 minus 0, which is 1. So therefore, the cumulative distribution function will look like following. So let's say this is u, this is the cumulative distribution function. So from minus infinity to 0, it will be 0. Then it will be equal to u from 0 to 1, and then it will be steady at 1. So, and mathematically we can write down in the following way. So it equals to 0 when u is below 0. It equals to u when u belongs from 0 to 1, and it's 1 when u is above 0. So this is the answer to this question. I hope I helped you. Thank you very much. Bye.